Today on Fun with Chemistry, we will be doing 3 practice problems from Chapter 1, Chapter 2, and Chapter 3. And today your professors will be Merrick and Ross. So for our first problem, Ross, will you begin reading for me?
Sure. How many grams are there in 25 pounds?
Alright, well you see, to convert this, you must know the conversion factor for pounds to grams. Do we know what that is, Ross?
I do. It is 453.6 grams. Is equivalent to 1 pound.
Pound. Alright. So, let's start with 25 pounds that we must convert. Now, when we use our train track method that we use here, we know that there are 453.6 grams in 1 pound. These cross and cancel out, and then 25 pounds times 453.6 grams equals 11,340 grams.
But wait, Merrick, we need significant figures.
Oh, of course. Well, the only number that is actually given in the problem is 25 pounds. 453.6, Ross, is a conversion. It doesn't count.
Okay.
It's a definite number. There's an infinite number of significant figures. So, we need 2 sig figs here. And to do that, we're just going to make these zeros by rounding down, and it's actually equal to 11,000 grams, because these 3 zeros are now not significant, but these 2 ones are. So, for Chapter 2, we're going to be doing example problem number 16, which is, which formula / name pair is incorrect out of these 4 formulas / name pairs. I'm going to let my colleague Ross take this one. Take it away, Ross.
Alright, so for the first one, we have iron and sulfate. Now, iron has a +2 charge.
Now, how do you know that, Ross?
Well, it says right here iron 2. That means it has a +2 charge.
Awesome.
Sulfate has a -2 charge.
And how do you know that?
How do I know that? You just have to know those things for this
Okay.
class.
I better study that then.
You should. So we cross both of them down, and we get 2, put parentheses, and then another 2. But since they're both the same, and we're just looking for empirical formula, they can be erased. So it's just FeSO4. So we're back to where we started.
You can simplify it to the simplest of ratios for the empirical
So
formula.
this one is correct. So A is not the answer.
Okay.
Now that brings us down to letter B. We have iron 2, iron subscript 2, and sulfite subscript 3. Now iron, in this case it's iron 3, so it's going to have a +3 charge because it says iron 3. And it's sulfite, so we know it's SO3, not 4, because that'd be sulfite, and it also has a -2 charge. So we bring both of those down, and then we get Fe2, and then SO3, in parentheses, 3. So we know this one is also correct. That brings us down to C. We have iron 2 sulfide, iron +2, sulfur -2. How do I know sulfur is -2? It is on the periodic table. It is the third from the left family. So it's going to want to gain 2 electrons to have 8 in its outer shell. So cross those 2 down. We get 2 and 2. Since they're the same, they can both be canceled out and written just FES. So that one's right. So D is the wrong answer. It's the right answer because it is incorrect, but I'll show you why. So we have iron 3 sulfide. So Fe was +2. This is
+3.
Oh, it is iron 3. Iron 3.
Iron 3.
So then we have sulfate. Now this is not sulfide. This, if we had just S, that would be sulfide. But since this is sulfate and this says sulfide, you know that this is the wrong answer. So the correct answer for the question is D.
Yay! Alright, next we're doing Chapter 3, practice problem number 19, which reads, combustion of a 0.9835 gram sample of a compound containing only carbon, hydrogen, and oxygen produces 1.9 grams of CO2 and 1.07 grams of hydrogen. What is the empirical formula of the compound? Ross, how do we start this problem?
All right, well, first we're going to have to write out all the equations. So we start out with our blank unknown that has
What we're
C,
trying to find.
H, and O. We don't know the numbers, so we can't write it in. Since it says it's a combustion reaction, we know it reacts with oxygen,
Okay.
which yields
What does yield, Ross?
carbon dioxide
Okay.
and water.
All right. Makes sense.
All right, so now that we have that, we need to know the masses of each of we're given the mass of carbon dioxide and water. Could you read those for me?
We are given a mass of carbon dioxide to be 1.900 grams.
900 grams.
All right.
And how about water?
Water has 1.070 grams.
Oh. Alright, so now that we have grams of each substance, since only carbon on this side is in the carbon dioxide, that's the only place that this carbon can go. So we can use the law of conservation of mass. So whatever mass of carbon is on this side, we know it has to be the mass on this side, and it's only found in our chemical that we are trying to find the empirical formula for.
See where you're
So,
going with this.
we will start with 1 mole of carbon dioxide.
All right. Because it's all we know.
Using our fence post method. And then we also know that there is, well, we need to know how many grams is in 1 mole of carbon dioxide. So we have carbon, which is 12.01 AMU, and we only have 1. And then we have oxygen, which is 16.00 AMU, and we have 2 of them, which gives us a total of 44.01 grams
Of carbon dioxide.
of carbon dioxide.
And that is the
So we put that
Okay.
44.01 grams CO2. Now,
Is equal to 1 mole.
now we need to know how many grams of CO2 we have. So we have 1.900 grams of CO2. Now we do that math and we get 0.04317 moles of CO2. Now that we have moles of CO2, we can calculate the amount of mass in that carbon. So we'll start with our 0.04317 moles of carbon dioxide. And then we have our conversion factor. There's 1 mole of carbon dioxide. In that 1 mole of carbon dioxide, there is 1 mole of carbon.
So these two cancel out.
Yes, so moles of carbon dioxide cancel out. Then we have 1 mole of carbon is equivalent to 12.01 grams of carbon, as found on the periodic table. Moles of carbon cancel out. We are left with grams of carbon, which comes out to be 0.5185 grams carbon.
Next.
Should we erase it?
Yes.
All right.
Next we go through the boards.
Trying to erase it first, or use a white sheet first? Yeah, erase that. Okay. So we had 0.5 to 1.85 grams of carbon.
Is that it? Somewhere? Here.
Okay, so now that we have grams of carbon, now we need to find grams of hydrogen. Since it only comes from water, we just have to find the moles of water and then find from that the grams of hydrogen. So we start out with
Same process.
1 mole of H2O And then in that 1 mole of H2O, we have 2 hydrogens. And then hydrogen is 1.01 AMU, and we have 2 of them. And then we have 1 oxygen, which is 16.00, giving us a total of 18.02 grams
Per mole.
per mole. So we have 18.02 grams H2O. Now we started out with 1.07 grams of H2O. That is what we produced. 0.070 grams H2O. Multiply that out and divide, and you get an answer of 0.05938 moles of water. Now, with moles of water converted, now we can find the grams of hydrogen. So now we have 0.05938 moles H2O. Now we can do, for every 1 mole of H2O, there are 2 moles of hydrogen. Subscript 2, 2 moles of hydrogen. So moles of water cancel out, left with moles of hydrogen. Now, for every 1 mole of hydrogen, there is 1.01 grams of hydrogen. Now, multiply that out, and you get an answer of 0.1199 grams of hydrogen.
All right. What's next, Ross?
Now that we have our grams of hydrogen and grams of carbon, we can take the total mass of our CHO compound, which was
0.9835 grams.
0.9835 grams. And then we can subtract the mass of the hydrogen, which is 0.1199, and also subtract the mass of the carbon, which was 5.5185, and get the grams of oxygen, since that's the only thing left. And then we get an answer of
0.3451 grams of oxygen.
1 grams of oxygen.
All right. So now, all we have to do is convert them all to moles and figure out our formula. All right. Now that we have solved for our masses of carbon, hydrogen, and oxygen, we must convert them into moles because moles are universal. And then we can find our ratio of carbon, hydrogen, and oxygen to create our empirical formula. So, first, let's start with carbon. We have 0.5185 grams of carbon, and we know that 1 mole of carbon is equal to 12.01 grams of carbon. From the periodic table, our grams will cancel out, and we get an answer of 0.04317 moles of carbon. Next, let's move on to hydrogen. We have 0.1199 grams of hydrogen, and we know from our periodic table that there is 1.01 grams of hydrogen per 1 mole of hydrogen, and that gives us an answer of 0.1187 moles of hydrogen. For our last one, we know that we have 0.3451 grams of oxygen, and there are 16.00 grams of oxygen per 1 mole, which gives us an answer of 0.02157 moles of oxygen. Next, to find our ratio, we divide by the smallest number of moles. We divide each answer. Now oxygen is our lowest one, so we'll be dividing it by itself, and that's going to give us a ratio of 1. So currently we know that there's at least one oxygen molecule in this ratio. So next we'll divide hydrogen by the same number, the number of moles of oxygen in the equation, 0.02157. We get approximately 2 carbon. Now that's
5.5.
Yeah, excuse me. 5.5 hydrogen. For carbon, we'll do the same. Divide by 0.02157, and for that one we get approximately 2. Now, our hydrogen is not an even number, so to make it an even number, we will then multiply by 2, because 5.5 times 2 will give us an answer of 11. So we times 2, get 11 hydrogens. Then we have to multiply everything else by 2. So we multiply oxygen by 2, you get 2 oxygens. And you multiply the carbon by 2, and you get 4 carbons. So we know that this magical, unknown compound is carbon 4, hydrogen 11, and oxygen 2. And that is your answer. Ta-da! Next time on Fun with Chemistry, we'll learn more things. Have a great day.